Alright, so before we go into the scheduling algorithms, let's take a look at scheduling criterion. So why? Because the scheduling algorithms are different criteria or different approaches you use to sequence the processes which are in the ready queue, right? So why do we need different algorithms? Why can we not just process everything in the order in which they come, or in a random order? Why do we need these different intricate logics like round robin, earliest deadline first, preemptive, non-preemptive? Why do we need all this? Is because we are trying to maximize and minimize certain quantities. We're not just randomly assigning processes to CPUs. If that was the case, we don't need these algorithms. We could just ask the OS to randomly pick up one process and randomly assign it to the processor. But there are quantities which we are trying to optimize because we are concerned about performance. So scheduling criteria is going to talk about what those quantities are and how we are trying to optimize them. Once we know that, we'll be able to look at our scheduling algorithms and decide whether this is good, is it optimizing what I want to optimize, is there a trade-off, is there a compromise I'm making in terms of something else, and so on and so forth. So that's what we're going to look at in scheduling criteria. What are we seeking to optimize while scheduling the processes? The first and foremost is CPU utilization. What do we mean by that? You want to keep your CPU busy and occupied for as long as possible. So if you have 4 processors in your computer, then it makes sense to keep all 4 running at all times instead of having one CPU idle and allocating all your tasks to the other 3. So that is what CPU utilization means in its simplest form. So the textbook content might be a little more nuanced, it might be a more technical definition, but ultimately you want to keep your CPU as busy as possible. That is what CPU utilization is about. Next up is throughput. So throughput is defined as the number of processes that are completed per unit time. So it is, of course, it's not like every second or every unit of time some number of processes are going to be completed. That's not going to be the case, because processes will have some time they need for execution. Let's say your P1 needs 10 units of time and P2 needs 8 units. Then for the first 7 units of time, there is no output at all. So throughput being defined as number of processes per unit time might lead to the confusion that it's not like every unit of time is going to produce an output. So what we mean is more like an average view. So if I have 10 processes and it takes, let's say, 60 seconds overall to complete, then the number of processes completed per unit time, you could say, is 10 by 60, is 1 by 6, and so on. So throughput is, it is not an instantaneous measure which is made at every point of time. It's more like an average view of the number of processes completed per unit time, and it aims to judge how efficient your scheduling is. So the greater your throughput, the more processes you are completing in less time, which means the more efficient you are being. So our idea is to maximize throughput. Obviously CPU utilization is also something we are trying to maximize as busy as possible. Similarly, throughput is also something we are trying to maximize. You want to get as much work done as you can in as little time as necessary. That's about throughput. Turnaround time is how long it takes to execute a particular process. So throughput was number of processes per unit time. Turnaround time is the time taken for one process. So from the moment your process enters the ready queue till the moment it has completely been finished and is terminated and it goes to the exit state, the total time taken is called the turnaround time. This includes the time spent waiting in the queue while scheduling has not been happened, the time spent in execution, the time spent in any input-output activities, if any, the time spent waiting while some other interrupt is being serviced, if any, all of it. From the moment the process enters the queue till the moment it has been completely finished and it reaches the terminate or exit state, the total time taken is the turnaround time, which obviously is something we are trying to minimize. We want to get tasks done as quickly as possible, meaning the turnaround time must be as low as you can make it. Next up, waiting time. Waiting time is the time the process spends waiting in the ready queue. So a process, as you know, enters the ready queue and then it waits while the OS picks it up and puts it in the processor. So if all processors are currently occupied with some other processes, then the processes in the ready queue will have to spend some time waiting until one of the processors is free and until the OS picks it up and assigns it to that CPU. CPU and processor are interchangeable terms here. So that time which it spends waiting is called the waiting time. Now here I would like to draw your attention to the preemptive and non-preemptive topics which we studied in a previous segment. So in non-preemptive we saw that once a task is taken out of the ready queue and put in a CPU, that's it. It gets executed, completed and it terminates. There is no putting it on pause or no intermediate wait. So in a non-preemptive scheduling algorithm, the waiting time will be the time between the process entering the ready queue and the process being picked up and put onto a CPU. That is all. Whereas in a preemptive scheduling algorithm, you have that waiting time, of course, from entering the queue till it is assigned to a processor. Also, there are intermediate waiting times in between. So some interrupt comes or some higher priority process comes or the time slice expires, then this current process will again be put in the queue and the other process will be taken and executed. Again, this current process will later be picked up from the queue and put into the CPU again. So there is an intermediate wait and that wait might have multiple iterations also, as you will see in the round robin example. So waiting time is in a preemptive scheduling algorithm, waiting time is the sum total of all those time instances which the process spends in the ready queue waiting to be allocated. Again, this is something we are trying to minimize. Finally, we have the response time. So response time is the time it takes to start responding. So the time between the process entering your ready queue and the first piece of output it yields. So a process while executing might yield output in multiple steps. So you have a program, it will first ask you to enter an input and then you enter the input, it will then do some computation and give you the output. So the first response could be the prompt asking you to enter an input. So please enter number X. That means the process has started execution and some response has come from its side. So the time interval between the process entering your ready queue and that first response coming out is called the response time, which again is something you want to minimize. You want to make the time as quick as possible. So to summarize, we want to design scheduling algorithms which maximize CPU utilization and throughput and minimize turnaround time, wait time and response time.